Okay, so I thought we'd come back and we'd look at some harder first principles questions. So we're looking at the limit as h approaches 0, f of x plus h minus f of x over h. All right, and this time our function is going to be 3x squared minus 4x. Okay, so in our function, the first thing I usually do is write down my coordinates. So my y2, my y1, x2 minus x1, remembering that this formula is just an extension of our gradient formula. So in here, I'm going to take my x coordinate, which is going to be x, and then it's just f of x, so whatever that is, so 3x squared minus 4x. Okay, and I'm going to take my x plus h, which is my x2, and my, sorry, you can probably hear my washing machine in the background, and my f of x plus h, so 3 bracket x plus h squared minus 4 bracket x plus h, okay? Remembering that you've got 2 lots of x in your function now, so that means you need to substitute in 2 lots of x plus h, okay? From here, we can then just start substituting that into our derivative formula. So I'm going to have f of x plus f dash of x equals the limit as h approaches 0 of f of x plus h, which is 3x plus h squared. Sorry, I feel like I'm going to run out of room here. Minus 4x plus h minus, and now I always put this in brackets because I need to remember that I'm subtracting all of f of x, not just the 3x squared. I'm subtracting that whole function. So I put that in brackets so that I don't get confused with the signs. And that's going to be all over h. Okay. Now I'm going to expand this out. It's up to you how you want to expand it. I'm just going to do it quickly, and I'm going to make another video on expanding. So you can kind of have a look at that in your own time if you would wish. But if you want to just put both the brackets in and then use FOIL, I guess that's up to you. So if I'm expanding this bracket, I'm going to have 3 lots of x squared plus 6xh plus h squared. By the way, if you are expanding it, pause the video now and do that yourselves, okay? Make sure that you're happy with what I'm doing, okay? Minus 4x minus 4h. Again, we're expanding that bracket too. And then I'm going to have minus 3x squared and then negative positive 4x. Okay, that's all over h. All right, so from here, we're up to the same kind of stage as we were before. And we can start cancelling things out. So I'm going to cancel out 3x squared here, 3x squared here, negative 4x and positive 4x. And what I should be left with is just everything that still has an h in my function. And that is how I know that I'm on the right track. So I'm left with 6xh plus h squared minus 4h over h. Now at this stage, if everything I've got left has an h in it, that means that I can factorize out an h from each of the top terms, and I can factorize out that h on the bottom. So I can cancel out that one here, this one from the squared, that one that's connected to the 4, and I can take away that denominator, and I'm going to get rid of that divide by 0 now. From here, again, if one of these terms didn't have an h, I wouldn't be able to remove it as a common factor, and I'd still have the divide by 0, and therefore I wouldn't be able to take the derivative. Okay, so from here, limit as h approaches 0, 6x minus 4 plus h, sorry, I've just switched those two around, so that's minus 4 plus h, and then I can take my limit as h approaches 0, and f dash of x is going to be equal to 6x, that h becomes 0 minus 4. Now, if I wanted to, I could then use this function and I could find the gradient at any point. So say I was finding my f dash of negative 3. I could substitute that in, 6, negative 3 minus 4. It's going to give me a value of negative 22. So I could say then at x equals negative 3, the rate of change, I could also just say f dash of x, f dash of negative 3, or I could say the gradient, or any of that, is negative 22. Okay, all right, we're going to look at another harder one. So just give me a sec. Need a new bit of paper. Is that page? Cool. Okay, so Now we're going to take a look at a non-polynomial function. So I'm going to have a look at f of x equals 1 over x. But again, we're going to work through the exact same process. So my derivative formula is the limit as h approaches 0, f of x plus h minus f of x all over h. Okay, again, exactly the same process that we want to work through. If I've got my x1 is x, that means my y1 has to still be 1 over x. Again, exactly the same as what f of x is. And if my x2 is x plus h, my y2 is going to be 1 over x plus h, substituting that x plus h in for x in our original formula. Alright, from here we can just sub this into our equation. So f dash of x equals the limit as h approaches 0. Now f of x plus h is 1 over x plus h minus f of x, which is 1 over x, and that's to all divided by h. Now I hate the look of that when you've got the double fractions. That never looks nice. It makes it way more confusing than what it needs to be. So I'm just going to rearrange it so it looks a little bit better. So I'm going to put 1 over h out the front, and then 1 over x plus h minus 1 over x. And again, what we're doing is we're still dividing by h, but I'm just going to write it as a fraction instead of a division, and I think it just looks a little bit better. Alright, so what we should all know and be very, very comfortable and familiar with is that whenever we're subtracting fractions, we need common denominators. So I'm going to times this whole function by x plus h, and I'm going to times this whole function by x, and then we're going to have our common denominators to work with. So the limit as h approaches 0, 1 over h. If I'm timesing this by x, I'm going to be left with x over x bracket x plus h minus 1 times x plus h is x plus h. Again, I'm going to put that in brackets because I know I'm subtracting that whole function. Okay, over x bracket x plus h. Right, now from here we can combine these. So we're looking at our limit as h approaches 0, 1 over h. Now we're going to have here x minus x, but then we're also taking minus h, and that's really important that we get that right. Okay, it's minus that x and we're minusing the h over x bracket x plus h. We can start to cancel from here. So take away the x. We're left with our limit as h approaches 0, 1 over h, negative h over x bracket x plus h. Now, our goal and our endpoint is still exactly the same as what we're working with our previous functions, where we want to get rid of any kind of divide by h's so that we can apply our limit as h approaches 0. So at this point, we've got a multiplier of negative h on top of our function, and we're also dividing by h. So we can cancel those out because our times and our divide cancel. So we can cancel that out. That's 1. Cancel that out. And what we're left with is our limit as h approaches 0 of negative 1 over, and we can expand this out now if we want, x squared plus xh. From here we can see that we don't have a multiplier of h going to 0 anymore, so we can apply our limit as h approaches 0, and we can just say that that's going to be f dash of x equals negative 1 over, if that h becomes 0, then so does that x, so negative 1 over x squared. Now for those of you that are familiar with the power rule, if we know that f of x equals 1 over x, okay, that's the same, using our index laws, that's the same as saying x to the power of negative 1. Okay, so when we're taking our derivative, we bring that power down to the front, we subtract 1, so that becomes negative 2, and then we can put it back in a fraction, so that becomes negative 1 over x squared, and we can see that they are exactly the same, so we're happy with that. Okay, so I hope this gave you guys a good intro into some more complicated functions. If you would like to try some of your own, then I would suggest giving some of these a go. I'll just write them up quickly, another blank page. I would suggest giving a couple of these a crack. So I want you to look at y equals, we'll say 4x cubed, y equals 1 on 2x, y equals 1 on x squared, and you could also try y equals square root of x. This one obviously is quite a lot different, but it's still exactly the same process, so I think you'd be okay with trying to work it out, and then maybe I can help you with it in class if needed. Okay, again, we are going to go over this in class. This is kind of just optional watching if you wanted to get ahead. Thanks very much. Okay, bye.